tonight. Let your map screen go dark. Now imagine standing somewhere unfamiliar with no road signs, no compass, and no blue dot telling you where to turn. Would you know which direction leads home? Do you know how an ancient hunter could leave camp for days, cross a forest, follow an animal, and still return to the same fire? Do you know how sailors found tiny islands hidden beyond an empty horizon? Could a footprint reveal how long ago someone passed? Could the shape of a wave point toward land that was still hundreds of kilometers away? And why can your phone guide you across a city while your own brain can forget where the car is parked? Get ready, because the answer is not that ancient humans had a magical sense of direction. The real answer is far more interesting. Before the journey begins, tap like, subscribe, and leave a comment telling what would make you feel most lost. A forest, a desert, an ocean, or a city with no phone. Ancient humans did get lost. Some wandered onto the wrong ridge, some followed the wrong river, some never returned. So the title hides a twist. Ancient humans were not impossible to lose. They were simply much harder to disorient inside the landscapes they knew. That difference matters. Today, getting lost usually means losing access to information. A battery dies. A signal disappears. A street name is missing. For an ancient traveler, navigation was not information delivered by a device. Navigation was a continuous relationship with the world. The ground was speaking. The sky was speaking. The wind, water, animals, shadows, smells, and stories were all part of the same map. Your body still contains part of that system, but without outside clues, it is less accurate than it feels. In 2009, researcher Jan Suman and his colleagues asked people to walk straight through a forest and across the Sahara without reliable landmarks. Under cloudy skies or in darkness, many slowly curved to one side. Some eventually walked in circles without realizing it. Why? Tiny differences in each step build up. One leg may push slightly harder. One turn of the hips may be a fraction stronger. Without a fixed clue outside your body, every small error becomes the starting point for the next one. Confidence does not prevent the circle. A horizon does. A star does. A known slope, a river, or even the direction of a steady wind can keep your internal estimate connected to the real world. This is the first secret. Ancient navigation did not depend on one perfect clue. It depended on many imperfect clues checking one another. The sun might suggest east. A valley might suggest south. Yesterday's wind might explain the angle of the grass. A familiar ridge might confirm the route. If one clue became unreliable, another could correct it. That is very different from blindly following a single arrow. Imagine moving through a thick forest. Every tree seems to repeat. The canopy hides the sun. The path bends around roots, rocks, and fallen trunks. A stranger sees green walls. An experienced traveler sees structure. Certain trees prefer wetter soil. Certain plants gather near streams. The ground rises almost too gently to notice, but rising ground may lead toward a ridge while falling ground may lead toward water. Bird calls change near open spaces. Air becomes cooler and damper near a river. A distant waterfall may be heard before it can be seen. Even the route itself becomes a chain of events. Pass the split tree. Cross the shallow stream. Keep the bright cliff on the right. Turn after the place where the ground becomes soft. That is not a map viewed from above. It is a map experienced in order. Psychologist Edward Tolman gave this idea a scientific name in 1948, the cognitive map. His experiments suggested that navigation was not merely a memorized list of turns. The brain could build relationships between places and use those relationships to find a new route. Decades later, neuroscientist John O'Keefe discovered place cells, brain cells that become active in particular locations. Maybrit Moser and Edvard Moser later discovered grid cells, which behave like part of an internal coordinate system. Your brain does not contain a tiny printed map. It contains patterns that help answer three constant questions. Where are you? Which way are you facing? How far have you moved? Ancient life trained those questions every day. A child did not learn the land during one lesson. The child followed adults to water, plants, hunting grounds, shelters, and neighboring groups. The same routes returned in different seasons. A dry crossing became a flooded crossing. A quiet meadow became dangerous during migration. A harmless patch of snow became thin ice after a change in wind. The map grew with experience. Now leave the forest and step onto open grassland. Here, the problem reverses. The sky is visible, but nearby cover is limited. Distant hills, isolated trees, rock towers, smoke columns, and the path of the sun can stay visible for hours. A traveler can keep one landmark at a fixed angle while walking, but distance becomes deceptive. A hill that looks close may take half a day to reach. Heat can blur its outline. A herd may block the direct path. The safest route may bend far away from the target, so time becomes part of direction. Where should the sun be when the group reaches water? How long should a certain ridge remain on the left? When should birds begin flying toward their evening roosts? A route is no longer only a line through space. It is a schedule. Now step into a desert. Dunes move. Footprints vanish. Heat hides detail. The landscape appears empty because the useful information is too subtle for an untrained eye. A desert traveler may follow stable rock, dry riverbeds, mountain silhouettes, stars, prevailing wind, known wells, and the memory of how long each section takes. The sharp side of a dune can reveal the recent wind, but wind can change, so one dune is never enough. A patch of vegetation may suggest hidden moisture. Animal tracks may point toward water, but only if the species and time of day are understood. Could a trail really tell time? Fresh edges crumble differently from old ones. Dew, wind, insects, and new prints alter a track. The answer is never a perfect timestamp. It is a careful estimate built from several changes at once. Ancient navigation was full of these estimates, not certainty, correction. Now follow a river. Rivers are pathways, boundaries, water sources, and giant directional arrows. Traveling upstream or downstream simplifies a journey, but rivers split, curve, flood, and disappear underground. The correct branch may be recognized by watercolor, current, bank shape, fish, plants, or the position of distant hills. Along a coast, another map appears. Tides expose rocks and crossings. Prevailing swells strike beaches at familiar angles. Seabirds leave land to feed and return toward evening. Clouds can form differently above islands. The smell of vegetation may travel over water. Floating branches, seeds, or land insects can announce a coast before the coast appears. Then the land vanishes completely. A canoe enters the Pacific, and the horizon becomes a perfect circle. This may look like the moment navigation becomes impossible. Instead, it reveals how far trained observation can go. Traditional Pacific navigators used a mental star compass. Stars rising and setting at known points gave direction. The sun helped near sunrise and sunset. Ocean swells could preserve the direction of distant winds, even when the local wind changed. Birds, clouds, currents, and the color of the sky added more clues. Navigator Mao Pielug passed this knowledge to Nainoa Thompson, who described navigation as constant memory. Speed, direction, time, course changes, stars, and wave patterns had to be carried in the mind. The navigator was not trying to point at a tiny island from thousands of kilometers away with impossible precision. The navigator could aim for a broad island region, reach the correct latitude, search for signs of land, find one island, and then use local knowledge to reach another. That is another secret. Ancient travelers reduced the size of the problem. Do not find one invisible beach, find the island chain. Do not find the camp from anywhere. Find the river, then the bend, then the ridge, then the smoke. Each successful step makes the next target easier. Now travel north, onto snow and sea ice. To an outsider, the Arctic can look blank. Snow covers paths. Fog erases the horizon. Moving ice changes the surface. But blankness belongs to the observer, not the landscape. Researcher Claudio Aporta documented how Inuit roots around Igloolik lived in personal and community memory. Old trails connected settlements, hunting places, fishing grounds, and safe crossings. Place names carried practical information, and route descriptions could rebuild a journey through spoken knowledge. Snow itself can hold direction. Wind forms ridges and hard surfaces. Ice cracks reveal stress and movement. Currents influence openings in sea ice. Familiar coastlines, stars, snow conditions, and prevailing weather patterns combine into a moving map. The route cannot be memorized as a frozen picture because the ice is not frozen in that sense. It changes, so the traveler learns relationships, not just shapes. A certain wind changes a certain crossing. A certain current weakens a certain edge. A certain season makes one route safer and another dangerous. That kind of knowledge is closer to understanding a living system than reading a row atlas. Now move to Australia, where direction can enter everyday language. Linguist Stephen Levinson studied speakers of Gugu Yimitir, a language that often describes space using geographic directions rather than relying mainly on left and right. An object may be north of another object, even inside a room. To speak accurately, you must keep track of direction. Language becomes practice. Every conversation can quietly exercise orientation. This does not mean every speaker has a supernatural compass. It means attention can be trained by culture until information that feels invisible to one person becomes ordinary to another. The same principle appears in stories, songs, and place names across many societies. A story can preserve the order of waterholes. A song can carry the rhythm of a route. A name can warn that a place floods, freezes, echoes, narrows, or attracts animals. A memorable character can attach knowledge to a landmark, so the instruction survives long after the original teacher is gone. The map is not stored in one head. It is distributed through the group. One person remembers a winter route. Another knows the coast. Another recognizes plants. An elder remembers a drought that changed the safe path. A hunter notices tracks that others miss. Could ancient humans navigate alone? Sometimes. But survival was rarely a solo puzzle. Groups shared routes, corrected mistakes, left signs, followed trails, watched children, and passed knowledge forward. That is why the strongest navigation tool was not the sun. It was culture. A single person can forget. A community can remember for generations. This also explains why familiar ancient landscapes were easier than unfamiliar ones. A skilled forest traveler could still become lost in open ocean. A master ocean navigator could still misread an unknown desert. Expertise was not a universal power. It was deep knowledge tied to a particular environment. Ancient humans also planned for uncertainty. They followed water when possible. They traveled at safer times of day. They watched weather before leaving. They carried knowledge of alternate shelters and seasonal foods. They turned back when clues stopped matching expectations. The best navigator was not the person who never made an error. It was the person who noticed the error early. That lesson feels strangely modern. Inchi, a phone gives an answer before you have to observe. Turn left. Walk 200 meters. Arrive. The tool is extraordinary, but convenience changes attention. When every decision is outsourced, the shape of the journey may never enter memory. Streets become instructions instead of relationships. A destination is reached, yet the route is not learned. That does not mean your brain is broken. It means your brain trains what daily life demands. Try walking a familiar route without checking the screen. Notice where the sun is. Predict the next turn. Look back after passing an intersection. Choose one distant landmark. Estimate how long each section takes. Your ancient navigation system will not suddenly become perfect, but the world will begin to contain more information. A street will have a slope. Wind will have a direction. Way, buildings will form a pattern. Sounds will reveal distance. The route home will become more than a moving target. So why did ancient humans never get lost? They did, but they lived inside maps that were constantly practiced, socially shared, emotionally remembered, and corrected by the real world. Their maps were made of rivers, stars, winds, tracks, waves, seasons, stories, and other people. Your map is often made of a screen. And tonight, when your map screen goes dark, you may discover that the world never stopped giving directions.